Good morning. So last class we discussed about how to find particular integration when q is equal to e power ax. So directly when q is e power ax, then we can find a particular integration, replace d with a, right? Now in this class we will discuss about particular integration when q is sin ax or cos ax, right? So first of all, pi when q of x is equal to sin ax or cos ax, right? So this is now how to find particular integration when q is sin ax or cos ax. Now first of all, actually what is particular integration here? Particular integration is 1 by f of d into q of x, right? So now here q of x is sin or cos. So first write this one is 1 by f of d can be write as some f of d square. Then here q is sin ax or cos ax, right? So when q is sin ax or cos ax, just here replace d square with minus a square. So what is a here? Now write, so here replace d square with minus minus a square. So into what is here? Sin ax or cos ax. So this is the particular integration. Now it is clearly, so here f of minus a square is not equal to 0. When we replace d square with minus a square, if denominator is not equal to 0, then this is the particular integration, right? Suppose here if f of minus a square is equal to 0, then what is particular integration? So now here particular integration, so 1 by f of minus a square if q is sin ax. So when we replace d square to minus a square, if denominator is 0, then here q is sin ax. Now the particular integration is right as minus x by 2a into cos ax. This is the particular integration. So when pi is 1 by f of minus a square into sin ax. So if denominator is 0, here f of minus a square is equal to 0. Suppose here sin in place of sin ax, so then write cos ax. Then what is particular integration here? So now here pi is 1 by f of minus a square into cos ax. Now in this case, what is particular integration? So just here write x by 2a into sin ax. This is the particular integration. Now this is also f of minus a square is equal to 0. So these are the conditions for particular integration for finding when q is sin ax or cos ax. So this is the when q is sin ax. Now it is when q is cos ax. So these are the conditions. Now we discuss about one problem. Right. The first problem is solve d square minus 3d plus 2 of y is equal to cos 3x. This is the problem. Now the solution of this equation. So what is the solution of this equation? Here it is in the form of f of d into y is equal to q of x. Then the solution is y is equal to yc plus yp. I mean complementary function and particular integration. So first of all we have to find complementary function. To find complementary function, first of all write what is given here. So here f of d, what is f of d here? F of d is d square minus 3d plus 2, right? This is the f of d. Compare with f of d into y is equal to q of x. So and q is cos 3x. Now to find complementary function, first of all write the auxiliary equation is, what is auxiliary equation here? The auxiliary equation is write as f of m is equal to 0. Now here write what is f of m? Write replace d square with m in f of d. Then we get m square minus 3m plus 2 is equal to 0. Now it is a quadratic equation. Now find roots from this by using minus b plus or minus square root of b square minus 4ac by 2a. Otherwise in another way, so here 1, here 2. So actually here we have 2. So what are the factors here? 2 can be write as 1 into 2 or minus 1 into minus 2. So what is possible here? Here we have minus 3. Then we use minus 1 and minus 2. So here minus 1 and minus 2. Then write factors as m minus 1 into m minus 2 is equal to 0. Now here m minus 1 is equal to 0 or m minus 2 is equal to 0. Then that implies here m is equal to 1 comma 2. Now here m is equal to 1 comma 2. Then here 1 and 2 are distinct roots. So if distinct roots, then what is solution here? The solution can be write as, solution means here complementary function. So what is complementary function for distinct roots? Now here write c1 e power x plus c2 e power 2x. This is the complementary function for distinct roots, right? Now next we have to find a particular integration. So what is a particular integration? Actually particular integration write as particular integration, that is yp. So that can be write as 1 by f of d into q of x. This is the particular integration. Now write what is f of d and what is q of x. Here f of d is d square minus 3d plus 2 and here q of x is equal to, what is q of x is given? So q of x is cos 3x. Now write in this one, so we get 1 by, so f of d is d square minus 3d plus 2 and q of x is cos 3x. Now it is 1 by f of d into q, q is cos 3x. In this case, so here we have to replace d square with minus a square. So what is a here? A is 3. Now here we have to replace d square with minus 3 square. That means minus 9. So write this one. Right here. So the particular integration yp is 1 by here d square minus 3d plus 2. Replace d square with minus 9 in this case. Right here minus 9 minus 3d plus 2, right, into cos 3x, right? Now this can be write as here minus 9 plus 2 is write as, so minus of 3d plus 7. So here we have minus 3d and minus 7. Then write minus of 3d plus 7 into cos of 3x. Now in this case write taking rationalize this one. So minus, rationalize means multiplying and dividing with 3d minus 7. So that's why here numerator 3d minus 7 by in this 3d plus 7 and to 3d minus 7, a plus b into a minus b, then that can be write as a square minus b square. So here what is a, what is b? A is 3d and b is 7. In this case write 3d square, that is 9d square minus b square. What is b here? 7. B square is 49 into cos of 3x. Right now here write minus of 3d plus 7 into cos 3x. Then again here in the denominator we have d square. Again d square, replace d square with minus a square. So what is a here? 3. Then write replace d square with minus a square. Here we get 9 into minus 9 minus 49. Right now here minus, so 3d of cos 3x. What is d? D is differential operator. What is the differential operator? D by dx. That means 3 into derivative of cos 3x. So cos ax. So that's why here 3 into derivative of cos 3x is minus 3 sin 3x. Right? So that's why here minus 9 sin 3x. 3 derivative of cos ax plus 7 cos 3x by what is here? Minus 81 and minus 49. So that's why here minus 130. Right? Now multiply minus. So here plus, this one is minus. That's why here we write 9 sin 3x minus 7 cos 3x by minus 130. This is the particular integration. Now write the general solution is, what is general solution here? General solution is y is equal to yc plus yp. Right? The general solution is, what is general solution? Here y is equal to yc plus yp. Now write y is equal to, what is yc? Here yc is c1 cos ax plus c1 e power x plus c2 e power 2x, and particular integration is here, this is yp. Particular integration is 9 sin 3x minus 7 cos 3x by minus 130. So write that one. So here c1 e power x plus c2 e power 2x minus 1 by 130, so into 9 sin 3x minus 7 cos 3x. So this is the our solution. So y is equal to yc plus yp. Here q is directly cos ax form, but in other way. So suppose here when q is not directly cos ax or sin ax, then what is suppose here cos a, in place of cos ax they give cos square x or sin square x. So when q is cos square x and sin square x, then how to find particular integration, right? So this is our problem. So go for next one. Okay, right. The next problem is solve d square minus 4 of y is equal to cos square x. So here q is cos square x or sin square x. Now first of all find complementary function, then particular integration, right? Now first of all write what is f of d here. F of d is here f of d. What is f of d? So compare with d square minus 4, I mean f of d into y is equal to q of x. Then here f of d is d square minus 4 and q of x is, what is q of x here? Q of x is cos square x. Now the auxiliary equation, to find complementary function, first of all we have to write auxiliary equation. The auxiliary equation is f of m is equal to 0. What is f of m here? M square minus 4 is equal to 0. Now here m square is equal to 4, then that implies m is equal to, what is m here? M square is equal to 4, then m is equal to plus or minus 2i. Here also roots are distinct roots. So distinct roots, when we get distinct roots, then the complementary function can be write as, so what is complementary function for distinct roots? So here roots are c1 e power plus or minus 2, then write c1 e power 2x plus c2 e power minus 2x. So this is the complementary function, that is yc. Right? Next, particular integration. So what is particular integration here? Particular integration is yp, then that is 1 by f of d into q of x. Now in this case, right, what is f of d here? F of d is d square minus 4 into q of x. What is q of x here? Q of x is cos square x. So here we have cos square x. So when we get cos square x or sin square x, suppose here cos square x, then cos square x can be right in the form of cos ax or sin ax. So but cos square x can be right as 1 plus cos 2x by 2. In place of cos square x we have to write 1 plus cos 2x by 2. So then, so actually this formula from cos 2x formula, what is cos 2x here? Suppose cos 2x is to 2 cos square x minus 1, so or 1 minus 2 sin square x. So actually here we have cos square x. So cos square x, 2 cos square x is, so then transpose to left hand side, here we get 1 plus cos 2x by 2, then that is cos square x. Suppose q is given, sin square x is given, then we have to write in place of sin square x here 1 minus cos 2x by 2. So this is also from cos 2x formula. So that transpose to left hand side 2 sin square x, then cos 2x to transpose to left hand side 1 minus cos 2x. So in this case sin square x can be write as 1 minus cos 2x by 2. If cos square x is given, write 1 plus cos 2x by 2. If sin square x is given, then write 1 minus cos 2x by 2. Okay. Now so this is the our problem 1 by d square minus 4 for 1 plus cos 2x by 2. Now this can be write as, that is equal to, so actually overall 1 by 2 is constant, right, in left hand side. Then here we have 1 by d square minus 4 into 1 plus 1 by d square minus 4 into cos 2x, right? Now here 1 by 2 into, actually here we have constant. So last class we discussed about when q is constant, then how to write. So here if q is constant value, so we have to write in that place. So 1 by d square minus 4 into, here constant can be write as e power 0x plus here 1 by d square minus 4 into cos 2x, right? Now 1 by 2 into, now here So this is 1 by f of d into e power ax form. So even q is e power ax, then replace d with 0. So here d with 0, what we get here? So 1 by 0 minus 4 into e power 0x. So plus, now it is 1 by f of d into cos ax form. So here cos ax, when we get q is cos ax, then replace d square with minus a square. So what is a here? A is 2. So that's why here we have to replace d square with minus a square. A is 2. That's why here write 1 by minus 4, this in place of d square, minus 4 into cos 2x. So that's why here finally we get, so this is e power 0x1, 1 by 2 minus 1 by 8. So e power 0x is 1. Then here minus 1 by 8 multiplying with 1 by 2. Then we get minus 1 by 16 into cos 2x. So this is this is the yp, right? So when we get yp, then write the general solution is, what is general solution? The general solution is y is equal to yc plus yp. So what is yc and what is yp? Here the yc is c1 e power 2x plus c2 e power minus 2x. Write in this way formula, c1 e power 2x plus c2 e power minus 2x plus yp. What is yp here? Minus 1 by 8 totally common. So write here 1 by 2 plus 1 plus here 1 by 2 cos 2x. So this is our solution. Y is equal to yc plus yp. Now in this problem we discussed when q is cos square x. So we have another problem. So in that case then how to find particular integrations, right? So next problem. What is our next problem? So when q is equal to sin ax, when q is equal to sin a sin b, or sin a cos b cos a sin b, or cos a cos b. So in this case, so how to find particular integration? Okay, we will discuss about when q is sin ax sin a sin b, or cos a cos b sin a cos b. Now the problem is, what is our problem? d square minus 4d plus 3 of y is equal to sin 3x cos 2x. Actually we suppose we have sin 3x plus cos 2x, then multiply 1 by f of d into sin plus 1 by f of d into cos. But here we have multiplication, right? So in this case, so how to find particular integration, right? First to find complementary function. Here compare with f of d into y is equal to q. Then write 1 by f of d is write as d square minus 4d plus 3, and q of x is equal to here sin 3x into cos 2x, right? So directly write auxiliary equation, m square minus 4m plus 3 is equal to 0. So from this, so what is here? 1 and 3. So that's why here 3 factors of 3. This can be write as 1 into 3 or minus 1 into minus 3. So what is possible here? Here we have minus 4. So that's why we have to write minus 1 and we have to take minus 1 and minus 3. So that's why write as factors. Then that is m minus 1 into m minus 3 is equal to 0. We get m is equal to 1 comma 3. So here also distinct roots. So for distinct roots, the solution yc is c1 e power x plus c2 e power 3x, right? This is common for finding a complementary function. Now go to for yp. So then yp is what is yp? 1 by f of d. What is f of d here? D square minus 4d plus 3 into q. What is q here? Sin 3x into cos 2x. So in this case, how to convert into sin ax or cos ax form? Suppose here not the multiplication, suppose plus or minus, then 1 by f of d into sin, 1 by f of d into cos. But in this case we have product. So now we have to convert this into some more difference of sine terms or cos terms. Okay, so first of all we have to learn the formulas. What are the formula for sin ax, sin a, sin b, cos a, cos b, sin a, cos b, right? Now here the formula, so sin a, sin b. What is sin a, sin b? Sin a, sin b can be write as cos of a minus b minus cos of a plus b by 2, right? If q is sin a sin b form, then we have to write cos a minus b minus cos a plus b by 2. For example, suppose q is cos a cos b form. So if cos a cos b form, in this case we write cos of a plus b plus cos of a minus b by 2. When q is cos a cos b, then write this formula. Here we have sin a cos b. So what is sin a cos b? For sin a cos b, write as sin a plus b plus sin a minus b by 2. So write this formula in place of sin a cos b. Suppose cos a sin b. Cos a sin b, just replace plus with minus. Right? Cos a sin b is sin a plus b minus sin a minus b by 2. So now here we have q is sin a cos b form. Now we use this formula. Right? Using that one, write 1 by d square minus 4d plus 3. Now here sin a cos b. Sin a is cos 3x and b is 2x. Right? And that formula we get sin of a plus b. So sin of a plus b is 5x plus sin of a minus b, 3x minus 2x. So x whole by 2. Right? Now here so 1 by 2 is a constant term, right? Now multiply f1 by f of d, 1 by d square minus 4d plus 3 into sin 3x, sorry, sin 5x plus 1 by f of d into sin. So that's why here write 1 by f of d square minus 4d plus 3 into sin x, right? So this is yp. Now here it is 1 by f of d into sin ax, here 1 by f of d into sin ax form. So when q is sin ax form, then replace d square with a minus a square. So what is right here? Okay. See, 1 by 2. Here sine ax. So in place of a here we have 5. So that's why replace d square with minus 5 square. So what we get? 1 by, so minus 5 square, so minus 25 minus 4d plus 3 into sine 5x plus here 1 by f of d into sine x. So that's why here write sine x y is 1. So replace d square with minus 1. So here minus 1 minus 4d plus 3 into sine x. Right? Now write 1 by 2. So here we get minus 25 plus 3 minus 22, here minus 4d, take common minus 4d plus 22 into sine 5x. So here minus 4d, here minus 1 plus 3, so that's why plus 2. So then that can be write as, write plus term first, 2 minus 4d into sine x. Okay. Now here in denominator 4d plus 22, in that 2 minus 4d. Then rationalize this. So when rationalizing, so here we get minus 1 into 4d minus 22 by, what is here, 4d plus 22 multiplying with 4d minus 22, then a plus b into a minus b, a square minus b square, 16d square minus 22 square. So 22 square is minus 484 into sine 5x. Here 2 minus 4d. So rationalizing we get 2 plus 4d by, here 2 minus 4d into 2 plus 4d, then we get a square minus b square, 4 minus 16d square into sine x. Right? Then again here in the denominator we have d square. Then replace d square with a minus a square. 1 by 2. Here multiplying minus 4d sine 5x. 4 into derivative of sine x. So derivative of sine ax is cos a cos ax. So that's why here we get 5 fours are minus 20 cos 5x. So here minus of minus plus, so 22 sine 5x by, here replace d square with minus a square, 16 into, in place of d square write minus 5 square minus 484 minus here 2 sine ax plus 4 derivative of sine ax. So sine ax derivative is cos x, sine x derivative cos x, here 4 minus 16, replace d square with minus a square. So here a is minus 1. So finally we get 1 by 2. This is a negative term. So 25 16. What is 25 16? So 400 minus 400. So here minus common, minus 400 minus 484 minus 884. Then minus common. So here we get 20 cos 5x minus 22 sine 5x by 884 minus here 4 minus of minus 20 we get. So 2 sine x plus 4 cos x by 20. So this is the our yp. So yp is, therefore finally write the general solution. What is general solution? The general solution is y is equal to yc plus yp. Right, what is yc here? Yc is c1 e power x plus c2 e power 3x, and the particular integration yp is this one. So right in this we get a required solution. Okay. Now This is a particular integration when q is equal to sin ax or cos ax. So we have next method, the particular integration when q is equal to x power k form. So when q is x power k, then how to find particular integration? To find particular integration when q is x power k, first of all we have to learn some formulas. So what are the formulas here? Now we discuss about that formulas. Now particular integration when q is equal to q of x is equal to x power k. So first we discuss of some formulas. Now what are the formulas here? Now 1 plus d inverse. What is 1 plus d inverse? 1 minus d plus d square minus d cube plus and so on. This is for 1 plus d inverse. Next 1 minus d inverse. So what is 1 minus d inverse? So 1 plus d square plus d cube plus and so on, right? Next 1 plus d whole power minus 2. So in this case 1 minus 2d plus 3d square minus 4d cube plus and so on. This is for 1 plus d power minus 2. Now suppose 1 minus d power minus 2. So in this case write formula 1 plus 2d plus 3d square plus 4d cube plus and so on, right? So these are the formulas we use in for finding particular integration when q is x power k. Okay. Now pi when q is x power k. First of all, pi is what is pi here? Actually 1 by f of d into q of x. Now in this case, so f of t can be write in the form of, so first of all write in the form of 1 plus or minus phi of d. First of all write f of d in the form of 1 plus or minus pi of d into q. What is q here? X power k. So after writing 1 plus or minus pi of d form, then this can be write 1 plus or minus phi of d inverse. So into x power k. Now write this expansion 1 plus some phi of function in d inverse. So 1 plus d inverse or 1 minus d inverse, 1 plus d power minus 2, 1 minus d power minus 2. So in this case use this formula, then multiply x power k with each term, we get the particular integration yp. So this is the procedure for finding particular integration when q is x power k. Okay, right? Now we discuss one problem. Okay, is it clear? Right. Now take one problem. What is that problem here? First one, solve d square minus 4d plus 4 of y is equal to 8x square. This is our problem. So now it is f of d into y is equal to q of x form. Now for the solution is y is equal to yc plus yp, same procedure. Then first of all find a complementary function for this. So here f of d is d square minus 4d plus 4. Now for to find a particular integration, first of all find a complementary function, then here f of d, first of write f of d here, d square minus 4d plus 4. Okay, and q of x is what is q of x in given one? So 8x square. This is given data. Now write the auxiliary equation for finding complementary function. What is the auxiliary equation? F of m is equal to 0. What is f of m? Replace d with m in f of d. So we get m square minus 4m plus 4 is equal to 0. Now it is also clearly quadratic equation. Now for to find roots of this equation, so here actually 1 and 4. Now here write 4, then factors 4 can be write as 1 into 4, so here minus 1 into minus 4, then 2 into 2 or minus 2 into minus 2. These are the possibilities. Now what is here? Here we have minus 4. So that's why what is possible in this case, in these 4 cases. So here adding these 2, these 4, here we get 5, here we get minus 5, here we get 4, here we get minus 4. So what is possibility? This is here we have minus 4. Now we can write, so this one. What are the factors here? So minus 2, that's why here write m minus 2, again minus 2, that's why m minus 2 is equal to 0. Now here m minus 2, m minus 2, so m is equal to 2 comma 2. Here we get roots are equal roots. So for equal roots, what is complementary function? So for equal roots, the complementary function yc is equal to, here write the solution is c1 plus c2x e power 2x. This is the solution for equal roots. Okay, right? Now for yp, what is yp? Then write yp is equal to 1 by f of d into q of x. Now here write 1 by, what is f of d in given one? D square minus 4d plus 4 into q of x. Q of x is 8x square. Now it is 1 by f of d into q form when q is equal to 8x square. So in this case, now it is x power k form. So when q is x power k, first of all write f of d in the form of 1 plus or minus pi of d. So to write 1 plus or minus, then here take constant term 4. Constant term means here lowest degree term, right? So here lowest degree term 4, so that is constant. Then that can be write as 4, take 4 common, so here we get 1 plus d square minus 4d by 4. So the into 8x square. Then you multiply with 4 again, we get this one. So here 4 cancel, d square minus 4d. So that's why d square minus 4d plus 4. So now 1 plus pi of d. Take into numerator. Actually here 8 by 4. Then that can be write as, here yp is now here 8 by 4 we get 2. Right? Now take into numerator 1 plus d square minus 4d by 4 whole inverse into x square. 1 plus pi of d inverse form. Now it is actually 1 plus some function in d. 1 plus d inverse. What is 1 plus d inverse formula? So now the formula for 1 plus d inverse is 1 plus d. What is d here? In place of d we have d square minus 4d by 4 plus d square. Sorry. Here actually minus 1 minus d plus d square. D square, in place of d we have d square minus 4d by 4. So whole square plus and so on into x square. Now it is 1 plus d inverse. Now write 1 minus d plus d square plus and so on, right? Now multiply with x square into 1 here, x square minus here d square of x square. D means d is the differential operator. Now d square 2 times derivative with respect to x, so here x square 1 time derivative is 2x, for second time we get 2, so 2 by 2 2 by 4, that is minus 1 by 2. Here minus of minus plus, now here 4d by 4, so we get d, right? D of x square. What is d of x square? Derivative of x square is 2x, right? Completed this one. Next, here we get actually after expansion, so we get d power 4 plus 8d square plus 16d square minus 8d cube. So in this case actually expand this, we get d power 4 plus 16d square minus 8d cube. We get these terms, right? So after multiplying with this one with x square, d power 4 of x square, 4 times derivative of x square, 4 times derivative of x square, we get 0. Here also 8d cube, d cube of x square is also clearly 0. So we get only this term, 16d square in this term. 16d square here by 4 square means 16d square by 16. So 16 cancel, we get d square of x square. What is d square of x square? So we get clearly 2, right? Now write this one, 2 here x square plus 2x, 2 minus 1 by 2. What is 2 minus 1 by 2? 3 by 2, right? So this is particular integration yp when q is x power k form. Now the general solution is, what is general solution? So the general solution is write as y is equal to yc plus yp, right? What is yc and what is yp? Here yc, what is yc here? c1 plus c2x e power 2x. Write this one, c1 plus c2x e power 2x, that is yc, and yp. What is yp here? So multiply with 2, we get finally 2x square plus 4x plus 3. So this is the solution of next we'll discuss more problems. Once again I will tell you. Suppose second one, d square plus 3d plus 2 of y is equal to x. F of t into y is equal to x, right? Q is x. Then so directly we find a particular integration. So this is to find complementary function process is clearly common. So that's where directly we write particular integration yp. What is yp here? Yp is 1 by f of d square plus 3d plus 2 into q. Here q is x. Now first the f of d can be write in the form of 1 plus or minus pi of d form. To write 1 plus or minus pi of d form, then take a constant term common. So here we get 2 is constant. Finally we get 1 plus d square plus 3d by 2 into x. Now take into numerator, this can be write as, so 1 by 2 1 plus d square plus 3d by 2 inverse into x. Now expand this and write expansion. We get 1 by 2 into what is expansion? 1 plus d inverse. So write here 1 minus d. So here in place of d we have d square plus 3d by 2 plus d square plus 3d by 2 whole square minus and so on into x. Actually in this problem we have x power k. Here k is equal to 1. So when k is equal to 1, x power 1, so in this expansion we have to write only d up to d terms. So right, so suppose we write d square, d cube, d power 4 terms, then clearly all terms are zeros. That's why we take only up to d terms. Now here 1 by 2 into, so multiply with x, x into 1, here we get x. So d square of x, so d square of x, one time derivative is 1, second time derivative is clearly 0. So that's where we have to write only up to d terms. Next minus 3 by 2d, so minus 3 by 2 into derivative of x is 1. So next terms d power 4, d cube and d square terms, all are clearly after multiplying with x, then we get clearly 0 terms, right? So that's why we take only up to d terms. So this is the particular integration. So then finally write the general solution y is equal to yc plus yp for every problem, right? So this is the particular integration when q is equal to x power k. And next class we will discuss about particular integration when q is equal to e power ax into v. So what is so when q is equal to e power ax into v, where v is equal to here only sin ax or cos ax or x power k. So we will discuss in the next class when q is equal to e power ax into v. Okay, thank you.